With tonicity, you had 3 options, right? What were your 3 options? So we had isotonic, hypotonic, and hypertonic. So isotonic meant what? What was equal? Yeah. That's. Ugh. Burn it. When I say both sides of the membrane, what do I mean? Inside and out. Fabulous. Hypotonic, what does that mean?
It causes it to swell. It's like they move on. They do the high, the H. I think, is that it?
The high to low. So hypotonic solution has less solute and more water in solution. And this is going to be, if it makes the cell swell, then it's going to be outside the cell. Right? Because you said that the water is going to rush in. Okay, so the hypertonic, what does hypertonic mean?
Low concentration of solute, high concentration of water.
Ah, that's hypotonic. I gave you the wrong. So it's going to be more solute, less water.
More solute, less water.
More solute, less water outside of the cell. And what does that mean? What happens to our cell here if it's hypertonic? It's shrizzle? Shrivel with a V. So this one here, the cell's going to shrink. We're going to learn some special words about that. Hypotonic, the cell will swell. And for this one, it remains the same size. If I were a plant, what type of solution would I like to be in? The hypotonic, right? That's how the produce department gets you at the grocery store.
I have a question. What does what does hypo mean?
Hypo means greater than. So if you're hypothyroid,
I was thinking like hypothermic.
that means that you have a fever.
Hypothermic,
Hyper.
Oh, hypo. That.
Hypo is greater than, hyper is less than.
Yeah, because like there's hypothermia.
Hyperthermia, right. Hypothermia is when the body temperature is too high. Hyperthermia. Sorry, hypothermia is when you're cold. Hyperthermia is when your temperature is too high.
So hypo is low and hyper is high.
So like hypothyroidism, we would have an underactive thyroid. A hyperactive thyroid, a hyperthyroidism is it would be overactive. These things here, isotonic, hypotonic, hypertonic, what do they all refer to? What terms when will we use those terms in describing what process? Not diffusion. Osmosis, right? So what type of, so we would use it for osmosis. And what is osmosis defined as? The diffusion of water. What is it going across? A selectively permeable membrane. Doesn't have to be a plasma membrane. I can give it an artificial one, right? Selectively permeable membrane. What type of transport is osmosis? Active or passive? So we know it's a type of passive transport. So passive transport. Help me remember. Perfect. So it requires No energy. And when I say energy, you think? ATP. Okay, what else can you tell me about it? That's it?
Like something gradient.
Something gradient.
Oh, yeah.
Very close. Something gradient.
High concentration.
Goes from, so it moves from an area
From high to low.
of high, I'm even going to write it out. It's so important. High concentration to low concentration. We said that the driving force is going to be, it moves down the concentration gradient. And put a little star there because that's my driving force, moving down that concentration gradient. What else can you tell me about passive transport?
What do you mean when it moves down?
It's going from high to low. What else can you tell me about passive transport? No ATP, moves from an area of high to low, goes down the concentration gradient. How many types are there? Three types of passive transport. What are they? Osmosis is totally one of them.
And facilitated diffusion.
Right, we have osmosis, we have diffusion, and you had facilitated diffusion. Diffusion is what? Movement of what? Movement of particles from an area of high to low concentration. Osmosis is the movement of water from an area of high to low concentration. And facilitated diffusion is the movement of particles from an area of high to low concentration with the help of protein channels. One more thing about passive transport, osmosis, or facilitated diffusion. Give me an example of what kinds of things diffuse. What kinds of things are going to undergo diffusion to get into a cell or out of a cell?
Salt.
Nope.
Water.
So like non-polar forces?
It's absolutely things that are non-polar. Are they going to be big or little?
Little.
So it's going to be small non-polar molecules like
The virus one?
no, you saw how a virus got in. It obviously did not diffuse. So an example would be things like oxygen, carbon dioxide.
So even though, because water can move to polar, right?
Right.
Because it's
Well, two reasons. It's small, and it actually goes through these special little pockets called aquaporins. But you don't learn about aquaporins until you're in AP Bio. What's the structure of my cell membrane?
Structure of migraine? Wait, that's I heard that.
Yeah, you did. And I'm not even going to bother responding to that.
Thank you.
The structure of the cell membrane.
phospholipid.
Phospholipid bilayers. So it looks like this. And then I've got this side like this. Right, if it's going or starting to make a circle. Why does it have to be non-polar to get through?
Because the head is polar.
So this part's polar.
But then the tails are not.
This part's non-polar. Very good. What are the tails made out of?
Fatty acid.
Fatty acid chains. What about the head?
Phosphate.
Phosphate and glycerol. Yep. So now let's go ahead and do what we were doing yesterday. That's a good review. I just like it that it looks all scribbly.
That looks good.
So if you take a look here, we've got these beakers, and they're better beakers than the ones that I drew. So if in your beaker A, you've got a 10% salt solution on the outside and a 10% salt solution inside the cell, let's just go ahead and humor me. Let's make our beaker and our cell. If we're talking about tonicity, what are we talking about? Osmosis or diffusion? Tonicity only refers to what? Get out.
Osmosis.
Osmosis. It only refers to osmosis. So do I care about the solute?
Yes. No.
No. Why do I need to know the solute? To tell me the amount of water, because osmosis is the diffusion of water. So if I have 10% salt solution in the beaker, how much water do I have? 90%. If I have 10% salt in my cell, how much water do I have? 90. And if I were to set this up as an inequality, these two are equal to one another. So my water is free to go both inside and outside at equal amounts. And so beaker A is going to be what tonicity? Isotonic, because iso means the same. Let's look at beaker 2. I always go B and C. So beaker 2, we've got 2% salt solution on the outside and a 10% salt solution in our cell. So if it's 2% salt solution on the outside, do I care about the salt? No, what do I need the salt for? To tell me the what? The amount of water. So how much water do I have? 98. How much water is inside my cell? 90. I'm going to set up an inequality. Nom, 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 nom. The alligator's mouth eats the big number. That becomes the tip of my arrow. So what's going to happen? The water is going to enter from the beaker into the cell. So the solution is hypotonic. Is the cell hypotonic? No, the cell is hypertonic. But the solution is hypotonic.
So when we're referring to something, we're referring to the solution.
It'll usually, it'll ask you in the solution, is this solution hypotonic or hypertonic? Yeah.
Is the solution the outside?
Yes.
Are we having a test on this or is this?
Yes.
When's the quiz?
Your quiz will be on, let's see, we're supposed to have a test on Friday, but Friday is a shortened day.
It is? Oh.
It's a shortened class period, so it's only 35 minutes. So we'll do a quiz on Friday, test on Monday, no review session for this test.
Is there actually is there a packet?
There's an extra credit packet, but there's not going to be any review session.
What's the test though? Like cell stuff?
Cells, cell theory, the scientist, organelles, cell transport.
Do we have a test on this?
All right, let's look at the next one. The beaker has 30% salt, so how much water does it have? 70. The cell has 10% salt, so how much water does it have? 90. Nom, nom, nom.
You enjoy it.
So what's going to happen?
It's gonna go outside of the hyper.
So we have hypertonic here. We're going to exit the cell, and my cell is going to shrivel. It's going to get smaller. Does everybody understand that? So if you take a look, here it is in color, Kati, so it doesn't look hairy. All right. Take a look at the bottom here. The little cartoon explains to you what's happening. So let's look at the one in the middle first. You've got water going out and coming in. So what is that going to be?
Isotonic.
That's my isotonic. And what's going to happen to the what's going to happen to the shape of my cells? So cells remain same shape. What about, let's look at this one here. We've got water coming in. They're getting so fat that they burst. So we have hypotonic. So the cells will swell and could burst. And we call this lysing, L-Y-S-E, to lyse, like a lysosome, or cytolysis. Cyto means cell, lysis meaning to burst. So cytolysis. You may want to write that down, Zach. So let's look at this one. All the water's leaving our poor blood cell. What would that be? Hypertonic. And what happened to our cell? It didn't get hairy. It will shrink. And we call this crenation. Not crenation. Crenation.
I actually thought you said cremation.
No. Crenation. It crenates. It gets smaller and shrinks. These are the only these terms only refer to animal cells. So what would be some practical applications of this? Well, how many of you guys have ever, on a nice summer's day, got strawberries? Me. Do you get strawberries? You ever cut them up and then what do? Cut them up and put them in the refrigerator. Before you put them in the fridge, do you sprinkle them with anything?
I wash them first.
Well, yeah, we wash them too, but that's just because we're clean. Do you sprinkle them with, you don't put salt on them, you put sugar on them. It's the other white powder that's in the kitchen, right? You put sugar on them. So if you if you cut up your strawberries, sprinkle them with sugar, stick them in the fridge for about 30 minutes and pull them out, they'll be in a strawberry syrup. The reason that happens is because how much water is in the sugar that you put on it? None, 0. So it's an area of low concentration. How much sugar is in your strawberries? A lot more than none. So the water leaves the strawberries, mixes with the sugar, and it creates a sugar syrup on the outside of your strawberries. If you're a boy, I'm pretty sure you're not, well, you might be in the kitchen cooking if you were like, I don't know, Aaron Sanchez or something, or Jeffrey Zakarian. But if you've ever seen a slug in your garden,
I've never put salt on them, but I've wanted to.
no, don't do that. That's horrible. What happens when you put salt on a snail or a slug? You kill them because their skin is an exposed membrane. So how much water is in the salt that you're pouring on it? 0. So that's a really low area of concentration, right? Water concentration. How much water is in the slug? Well, it's awful gooey and juicy looking to me. So a lot. So the water leaves the cells of the slug or snail and it shrivels up and dies. You horrible person, you.
There was a slug on my dog.
Let's take another example. Let's say that you have let's say you've got a fish tank. Right? And you went to PetSmart and your fish tank is a freshwater fish tank. How much water is in the solution on the outside? If it's fresh water.
Oh, I thought you meant outside the fish tank. Yeah, it doesn't apply.
So yeah, inside, so you have 100% water. Now let's say that you go and you get a saltwater fish. And you're going to put your saltwater fish in there because you're not very bright.
Is it bad that I can't draw a fish?
There's my mean saltwater fish. You put it in there. Your saltwater fish is used to living in an isotonic in an environment that has about 70% water. So let's say he's got 70% water. What's going to happen?
Water's going to go in the fish and it's going to swell up.
His cells are going to swell and cytolyse inside of him and your fish will die.
That's horrible.
It's horrible with the fish. What about the slug? What about the slug?
Slugs are nasty.
Eat slugs.
Oh,
I like snails.
Harry Potter.
So what would happen if you put a freshwater fish into a saltwater tank?
It gonna die.
All the water will go out of it.
All the water will go out and their cells would shrivel up. Yes, that's why you can't just go like, oh, I've got a freshwater tank, but oh, I love this saltwater fish. Oh, I'll put them in there. No, it's going to die. Right?
That's so sad.
You're not going to see it on a cellular level unless you've got X-ray vision, Marvel Man, okay? I mean, you know?
Well, what would you see though? Would it just like...
You would go to bed and you would come back and your fish would be floating upside down.
What if you like watched as
It would die.
Would it just like, would you be able to see it getting bigger? Or
No, because it's on a cellular level that it occurs. And then the cells, individual cells
So
start
it
bursting.
would just be swimming around and then it would just float to the surface and die.
Yeah.
Wait, so if I was like all like only wait, is he facilitated diffusion also?
Yep, we're getting ready to do it. So our last type is passive transport by proteins, and this is our facilitated diffusion. Passive transport via those proteins. So this is our last type of passive transport. Hey, if we're finishing passive transport today, what do you think we'll finish tomorrow? Active transport, and that'll be all the information for your test. So passive transport of materials across the membrane using transport proteins. So we have special proteins called transport proteins. It's called facilitated diffusion.
So our test is next week, correct?
Connor, I've already said this.
I know you said that it was on Friday, but then we were...
No, I said it's on Monday because of Friday you have a shortened class, but you still have a quiz on Friday.
Okay, that's fine.
Oh, I'm glad you agree, sir.
Is it open now or is it closed?
Your quiz is closed.
Oh.
Sorry, close note. Always closed. You goofball. Nice try. This one, however, is not multiple choice.
What?
No.
This test is not multiple choice. Sorry about your luck. All right, plasma membrane. If you take a look, here's your plasma membrane, and you've got these embedded protein channels here. So these embedded protein channels, now facilitated diffusion, I like to think about it. Let's say that Connor's going to the movies on a Friday night, right? And Connor and 9 of his closest friends are going with him.
Am I close to
No, can I get a
Nope. He's taking 9 of his closest friends. So they get to the movie theater and they realize they've only got enough cash for 8 tickets. So Connor, being the stand-up guy that he is, says, you know what? I am not going to leave you out here in the parking lot. We're going to sneak you in. So they go up to the movie theater and they buy 8 tickets. And all 10 of them go into the theater.
Oh,
And,
9.
Okay, well, all 10 of them. Connor and his 9 friends. 9 plus 1 is 10, right, Zach?
Yes.
But they
Okay.
don't get 8 tickets. That means 2 have to sneak in.
Exactly. So what they do is they go up to the guy who's, at the ticket thing, the guy who tears your tickets when you walk in, and that guy's working for $5 an hour and he hates his job and he's just thinking, God, when can I get off? Especially on a Friday night. He's looking at you like, oh, how come you guys are out on a Friday night having fun and I've got to be at work? And he's all grumpy, right? So he takes all the tickets, you hand it to him in a stack. Now he's not going to sit there and take one ticket and say, okay, you go in. Okay, you go in. He's going to take that whole stack of tickets. He's going to take the whole stack and tear them, shove them in the little box, and hand the stack back to Connor, right? And then all of his friends are going to walk in. So they've facilitated the diffusion of 2 of his friends who did not pay to get across the membrane. So what they've done is it was like the protein channel hides them from the hydrophobic portion of the cell membrane and allows larger and hydrophilic molecules to go in, much in the same way.
Wait, people sneak in a movie?
So, I've never have, but yeah, I had a friend in high school who did it all the time.
How, like, wait,
It's more like
when there's
sneaking
big
already.
crowds, how do they know, like, they're not?
They don't. That's the point.
Oh, that's...
I know. I would feel guilty as well.
Yeah,
I also know someone who would buy 1 ticket in the morning and then just like go to the bathroom when they were cleaning the theater and then go back and see a different movie at like all day long. That's what he did.
Oh. Wait, if you get caught, don't you go to, like...
No, but they just throw you out. There's places now that you can just order, like, you can, like, it's a touchscreen thing and you can get your tickets
Facilitated
right there.
diffusion,
So,
a special carrier protein with a central channel acts as a selective corridor which helps molecules move across the membrane. These special carrier molecules that form the protein channel bind only to a specific molecule, such as a particular sugar or amino acid. Once the molecule binds to the carrier protein, this protein helps or facilitates.
It says that it binds to a specific sugar or amino acid. What can you tell me about sugars and amino acids? They're larger. They're not macromolecules by themselves, but they make macromolecules, but they're larger and they're polar. Remember, they have some portion of them that allows them to be polar. So facilitated diffusion is going to help with large polar molecules. Helps with large polar molecules. Helps with large polar molecules.
Wait, say what helps with it, though?
Facilitated diffusion helps move large polar molecules. Large polar molecules.
Long bone. Helps with what? Oh my god.
Helps move large polar molecules. Are you serious?
The diffusion process by changing shape and moving the molecule down its concentration gradient through the membrane into the cell where it is released. Facilitated diffusion is similar to simple diffusion in that both involve movement of molecules down their concentration gradient, and this movement is carried out without any input of energy. However, in facilitated diffusion, the movement of molecules will only take place if it is facilitated or helped by a special protein carrier in the membrane. Facilitated diffusion can occur in either direction depending on the concentration gradient. If there is a higher concentration of the particular molecule inside the cell, the same carrier protein would then transport the molecules out of the cell.
Channel proteins, they form channels and allow specific molecules to flow through. So again, in the specific molecules. Facilitated diffusion.
Which is helps move large polar.
Well, it's diffusion of particles with protein channels. Moves large polar molecules. Why does it move large polar molecules? Because they're too big to sneak past those hydrophobic tails. All right, so let's close it out here. So you have, let's see, which one is this?
Combine cell membrane